Question 1. Your team needs a quick way to edit scripts and run commands in Azure without installing CLI tools on local machines. Which option is best? Select one answer. A. Azure Marketplace. B. Azure Cloud Shell. C. Azure Advisor. D. On-premises PowerShell. Correct answer. B. Azure Cloud Shell. I'm going to explain now, so follow along as we connect each choice to how Azure operations work. First, Azure Cloud Shell is browser-based, which means no local setup, and it includes the Azure CLI, PowerShell, and a built-in code editor, so teams can open a browser and run scripts immediately. Next, Azure Marketplace is primarily for discovering and deploying solutions and images, not for interactive CLI sessions, so it doesn't meet the requirement for quick command execution. Moreover, Azure Advisor gives best practice recommendations for cost, security, reliability, and performance, but it doesn't provide a shell to run commands. Finally, on-premises PowerShell would require installing and maintaining modules on each machine, which contradicts the need to avoid local installs. For example, a new contractor can log into the Azure portal, launch Cloud Shell, edit a script in the embedded editor, and run AZ or PowerShell commands within minutes, thereby accelerating onboarding without touching their laptop configuration. Honk of the left hands. Question 2. Fill in the blanks by selecting the correct options from the drop-down menus. In Bash, you can run commands interactively in a console or automate tasks by writing scripts. I'm going to explain now, so follow along as we connect each choice to how Bash actually works. First, console is correct because you can type commands directly into a terminal and get immediate feedback, for example, running ls or echo to verify a path. Furthermore, scripts are right, since saving a sequence of commands in a .sh file lets you repeat tasks consistently, such as provisioning users or rotating logs on a schedule. Meanwhile, the kernel handles low-level system operations and does not run user commands directly. Likewise, a desktop environment focuses on graphical interfaces rather than shell execution. Finally, BIOS initializes hardware before the operating system starts, so it has nothing to do with Bash usage. Question 3. For each statement below, indicate whether it is true or false. Commands in Bash can be typed interactively in a console. Answer true. Scripts in Bash allow multiple commands to be executed together. Answer true. Bash does not support running commands directly from the console. Answer false. Scripts in Bash are limited to containing only one command. Answer false. I'm going to explain now, so follow along as we connect each statement to how Bash actually works. First, typing directly in a console is Bash's interactive mode, so you run a command like ls and see output immediately. Next, scripts bundle many commands into a single file, so you can run setup.sh to create folders, install packages, and configure permissions in one go. However, the claim that Bash cannot run commands from the console is the opposite of reality, because the terminal is exactly where Bash executes ad hoc commands. Likewise, scripts are not limited to one command. Instead, they often chain dozens of steps with conditionals and loops to automate real-world tasks, such as provisioning a VM, initializing Git, and deploying an app in sequence. Question 4. For each statement below, indicate whether the answer is true or false. Commandlets in PowerShell can be developed in .NET or .NET Core. Answer true. The help alias displays help with pagination, unlike get help. Answer, get member is used to list all installed commandlets. Answer false. Developers should always match commandlet verbs with their function descriptions. True. I'm going to explain now, so follow along as we connect each statement to how PowerShell actually works. First, commandlets are compiled components built on .NET or .NET Core, so they naturally integrate with the framework types and runtime. Next, the help alias pipes output through a pager, which makes longer help topics easier to read interactively, whereas calling get help without paging can flood the console. However, get member examines the members of objects returned by commands, such as properties and methods from get process, so it does not enumerate installed commandlets. Finally, consistent verbs matter because users rely on standard verb-noun patterns. For example, get process retrieves data while set execution policy changes a setting, and aligning verbs with behavior keeps scripts predictable and discoverable. Question 5. Which ARM template section lets you avoid specifying API versions for each resource individually? Select one answer. A. Variables by profile. C. Parameters. D. Functions. Answer B. By profile. I'm going to explain now, so follow along as we connect each choice to how ARM templates really work. First, A by profile defines a set of resource provider API versions in one place, so you do not repeat API version on every resource. Consequently, your template stays consistent and easier to maintain across environments. Furthermore, imagine a template that deploys to 10 storage accounts and key vaults. By updating the API profile once, all those resources inherit the right versions without touching each resource block. However, variables only hold computed values to simplify expressions and do not control API versions, so they cannot replace API profile for this purpose. Likewise, parameters accept input at deployment time, such as names or locations, yet they do not map provider versions automatically. Finally, functions add custom expression logic inside the template, but they are unrelated to choosing or propagating API version values, which is exactly what API profile handles. Question 6. Which two best practices apply when defining parameters in ARM templates? Select two answers. A. Provide default values whenever possible. B. Hardcode usernames for consistency. C. Use parameters for environment-specific settings. D. Define all parameters as secure string. Correct answers. A. Provide default values whenever possible. C. Use parameters for environment-specific settings. Shifting into the reasoning now so it locks in. First, defaults improve usability because deployers can accept sensible presets while retaining the option to override, for example, a default location or SKU that speeds up routine deployments. Next, environment-specific parameters make one template reusable across dev, test, and prod. You simply pass different values such as standard LRS in dev and premium LRS in prod, which keeps version sprawl under control. Meanwhile, hard-coding usernames introduces security and maintenance risks as accounts rotate and managed identities become standard. Finally, marking every parameter as secure string is unnecessary. Only secrets like passwords or keys should be secured, while ordinary values remain plain for readability and validation. Question 7. For each ARM template element, drag it to the correct description defines the location of the JSON schema file. Answer schema. Specifies the template version number. Answer content version. Holds user-defined values provided at deployment. Answer parameters. Lists the resources to be deployed. Answer resources. Returns values at the end of the deployment. Answer outputs. Quick walkthrough so the logic sticks. First, schema points tools to the validation file, so editors can lint and autocomplete the template reliably. Meanwhile, content version tracks the template's own revision, helping teams document changes between releases. Additionally, parameters capture deploy time inputs like location or SKU, thereby letting one template flex across dev, test, and prod without edits. Next, resources declares the actual Azure services to create or update, for example, a storage account or key vault, which is the core of the deployment. Finally, outputs returns useful values after deployment, such as a storage endpoint URI, so subsequent scripts can consume them automatically. Question 8. Fill in the blanks by selecting the correct options from the drop-down menus. Microsoft Identity Manager MIM integrates with Microsoft Entra P1 or P2 to provide a hybrid identity solution by bridging on-premises authentication stores such as ADDS, LDAP, and Oracle. Now let's unpack why these fit so well. First, Entra P1 or P2 includes the licensing and features needed for MIM integration, so enterprises can synchronize identities and enforce policies consistently across clouds and data centers. Next, hybrid identity is the goal because users sign into cloud apps while accounts still originate on premises, which MIM supports by flowing identities between directories. Furthermore, ADDS, LDAP, and Oracle are classic on-premises identity stores that MIM can connect to, thereby normalizing identities and attributes into Entra for single sign-on and lifecycle management. For instance, when HR creates a user in an Oracle directory, MIM can provision the account into ADDS and surface it in Entra, so the employee immediately accesses SaaS apps without duplicate manual steps. Question 9. For each statement below, indicate whether the answer is true or false. Microsoft Entra Domain Services is enabled for a specific Azure Virtual Network, allowing resources on that VNet to consume the managed domain. Answer: true. The managed domain is fully compatible with locally deployed ADDS, supporting domain join, group policy, Kerberos or NTLM, or LDAP. Answer: true. You can extend the Microsoft Entra Domain Services directory schema to add custom attributes. Answer: false. Built-in GPOs in Microsoft Entra Domain Services can be targeted to OUs using WMI or security group filtering. Switching gears, let's connect the dots succinctly. First, the service is scoped to a VNet, so only resources joined to that network can use the managed domain, which is why the first statement holds true. Moreover, Microsoft Entra Domain Services implements the classic AD protocols and features. Therefore, legacy apps can still domain join and consume group policy just like on-premises. However, schema extension is not supported in the managed service, so adding custom attributes isn't allowed, making the third statement false. Finally, the built-in GPOs are limited and cannot be targeted with WMI or security group filtering. Consequently, the last statement is also false. Question 10. For each statement below, indicate whether the answer is true or false. A deleted user remains in a suspended, restorable state for 30 days. Answer: true. After permanent deletion starts, the user can still be restored for 7 days. Answer: false. You can view and restore deleted users from the Microsoft Entra ID user interface. Answer: true. Licenses in this exercise are assigned to a group rather than directly to the Chris Green user. Answer: true. Now let's walk through the reasoning so it sticks. First, Microsoft Entra ID keeps soft deleted users for 30 days, so recovery is straightforward during that window. Next, once a permanent delete is initiated, restoration is no longer possible. Therefore, the 7-day recovery claim is incorrect. Meanwhile, the Entra Admin Center provides a deleted users view where you can restore or purge accounts, which confirms the third statement. Finally, assigning licenses to a group such as marketing lets members inherit the product automatically. Consequently, Chris receives the license through group assignment rather than a direct per-user assignment. Question 11. For each device state, drag it to the appropriate boxes in the correct match column to match it against its primary audience or device ownership. Primary audience, BYOD and mobile devices. Answer: Microsoft Entra registered. Device ownership, user or organization. Answer: Microsoft Entra registered. Primary audience, cloud only or hybrid organizations. Microsoft Entra joined. Device ownership, organization. Answer: Microsoft Entra joined. Primary audience, hybrid orgs with existing on-prem AD. Answer: hybrid. Microsoft Entra joined device ownership, organization. Answer: hybrid Microsoft Entra. Time to break down the logic so it sticks. To begin with, Entra registered targets bring your own device and mobile scenarios, so registration brings personal devices under light management, while ownership can remain with the user or the organization. Meanwhile, Entra joins suits cloud-first or hybrid shops using organization-owned Windows devices that sign in with Entra accounts, thereby enabling policy and SSO directly from the cloud. Furthermore, hybrid Entra joined fits enterprises that still use on-premises AD. Devices are domain joined on-site, yet also registered with Entra. Thus, the organization remains the owner, and cloud management features light up. For example, a contractor's phone would be Entra registered, a corporate laptop for a cloud-native team would be Entra joined, and a finance desktop still using on-prem group policy would be hybrid Entra joined. Question 12. Arrange the Azure management hierarchy from the broadest governance scope to the most granular. Management group, subscription, resource group, resource. All right, let's walk through why this order makes sense. To begin with, management groups sit above subscriptions, so policies and RBAC can flow down to many subscriptions at once. Next, subscriptions define billing and access boundaries. Therefore, they contain multiple resource groups and inherit management group governance. Subsequently, resource groups organize related services, so you can deploy, secure, and monitor them together within a subscription. Finally, resources are the individual items like VMs, VNets, and storage accounts, which represent the most granular level you configure and manage day to day. Question 13. Fill in the blanks by selecting the correct options from the drop-down menus. An Azure policy definition is described in JSON and expresses rules and effects. A policy initiative groups multiple policy definitions toward a specific goal, enabling centralized control and compliance tracking across resources via the compliance dashboard. Quick step through of the logic before we move on. A policy definition is the fundamental unit that states conditions and effects, so it must be authored in JSON to be parsed and enforced consistently by Azure Policy. A policy initiative is simply a collection that bundles many definitions toward a theme like tagging or security baselines, which lets you manage them together for consistent governance. Centralized control follows naturally because you assign the initiative at scopes like management groups or subscriptions, and the constituent policies inherit down. Finally, the compliance dashboard aggregates evaluation results so you can see overall compliance, drill into non-compliant resources, and remediate as needed without hunting through individual policies. Question 14. Your developers defined an application in Tenant A and want users in Tenant B to sign in with their Tenant B identities without duplicating the app code. What must happen in Tenant B? Select one answer. A. Deploy domain controllers in Tenant B and join the app server to the domain. B. Clone the application object into Tenant B and delete the original in Tenant A. C. Create an organizational unit in Tenant B and link the app to it. D. Create a service principal for the application by registering or consenting to it in Tenant B. Correct answer D. Create a service principal for the application by registering or consenting to it in Tenant B. All right, quick explanation, so this sticks. The application object lives in Tenant A, but each tenant that uses the app needs its own service principal, so registering or consenting in Tenant B creates that local identity and permissions for the app to operate there. Meanwhile, deploying domain controllers is unnecessary because this is an Entra ID Cloud app scenario, not a server domain join requirement. Cloning or deleting the original application isn't needed since cross-tenant access relies on the same app definition with tenant-specific service principals. Finally, Entra ID doesn't use organizational units like on-prem AD, so creating an OU would not enable app sign-in at all. Question 15. A new employee is added to your HCM system. You need their account and group memberships automatically created in a SaaS app that supports SCIM. What should you implement to meet this requirement end-to-end? Select one answer. A. Schedule weekly CSV imports into the SaaS app and run a PowerShell sync to Entra ID. B. Invite the user as a guest and assign an app role manually. C. Create a conditional access policy requiring compliant devices. D. Configure the Microsoft Entra Provisioning Service to the app's SCIM endpoint to provision users and groups automatically. Correct answer D. Configure the Microsoft Entra Provisioning Service to the app's SCIM endpoint to provision users and groups automatically. Switching into the explanation so it clicks. First, Entra Provisioning uses SCIM to listen for HR-driven changes and automatically create, update, and deactivate users, plus group memberships in the SaaS app, which gives you true lifecycle automation. Meanwhile, weekly CSV jobs are batchy and manual, so they miss near real-time updates and often drift from HR data. However, inviting a guest and assigning roles is a one-off access step, not provisioning based on HCM events. Likewise, conditional access only governs sign-in conditions, therefore it doesn't create accounts or groups. For instance, when HR hires Priya, the provisioning service pushes her profile and marketing group to the app within minutes. And when she leaves, deprovisioning happens automatically without scripts or spreadsheets. Question 16. What best describes the relationship between an Azure account and subscriptions? Select one answer. A. A subscription creates multiple Azure accounts by default. B. Resources are created at the account level, not within subscriptions. C. You can have only one subscription per Azure account. D. An Azure account can own multiple subscriptions, and resources are created within a chosen subscription. Correct answer D. An Azure account can own multiple subscriptions, and resources are created within a chosen subscription. All right, let's make sense of it quickly. First, an Azure account is simply the identity and billing owner, whereas subscriptions are the containers that define scope for billing, access, and policy. Therefore, resources live inside subscriptions, not at the account level. Moreover, an account can hold many subscriptions, which lets you separate cost centers or environments like dev, test, and prod, while still paying from the same owner account. Conversely, a subscription does not create multiple accounts, and you are not limited to a single subscription per account, so options A and C fall apart immediately. In practice, a company might keep one account for finance, but run separate subscriptions for each department, deploying resources only in the appropriate subscription to keep RBAC and cost tracking clean. Question 17. You begin a hands-on exercise labeled BYOS, but your directory currently has no Azure subscription. What must you do before you can deploy any resources for the lab? Select one answer. A. Proceed without a subscription. The portal allows deployment in read-only mode. B. Create or attach an active Azure subscription to your account. C. Use only a GitHub account to complete the lab. D. Borrow another user's subscription by switching directories without consent. Correct answer, B. Create or attach an active Azure subscription to your account. Quick pause. Let's make sense of that choice. BYOS literally means bring your own subscription, so deployment requires an active subscription tied to your account. Otherwise, the portal won't let you create resources. Conversely, read-only mode can't deploy anything, so option A fails. Likewise, a GitHub identity alone doesn't grant an Azure subscription, so C won't help. Finally, switching to someone else's subscription without proper consent or access is inappropriate and unreliable, so D is out. Question 18. How deep can the management group hierarchy extend beneath the tenant root group? Select one answer. A. 6 levels. B. 3 levels. C. 2 levels. D. Unlimited. Correct answer. A. 6 levels vetted. Quickly shifting into the why so it sticks. First, Azure limits nesting to 6 levels beneath the tenant root group, ensuring governance stays manageable and policy evaluation remains performant. Moreover, this cap prevents overly complex inheritance chains where RBAC and policy assignments become hard to reason about across many tiers. Consequently, options for 3 or 2 levels are too restrictive for real enterprises that often need several tiers like Corp, Region, and Environment. Likewise, unlimited depth would complicate troubleshooting and slow evaluations, so Azure enforces a practical ceiling. For example, you might structure Corp at the top, then Region, Business Unit, Environment, Platform, and Workload as 6 levels, comfortably fitting under the root while keeping governance clear. Question 19. Which features are supported on Microsoft Entra joined devices? Select 2 answers. A. Self-service password reset SSPR. B. Cloud-only conditional access is unavailable. C. Native support on Windows 10 or 11 Home. D. Windows Hello Pin reset. Correct answers. A. Self-service password reset SSPR. D. Windows Hello Pin reset. Now here's the quick reasoning so it sticks. First, Entra joined devices support SSPR, allowing users to reset their own passwords after verifying identity, which reduces help desk load and speeds recovery. Moreover, these devices include the ability to reset a Windows Hello PIN, so users can get back in even if they forget their PIN after a policy change. Conversely, conditional access isn't unavailable-only scenarios. Rather, it's a core capability used to enforce compliant access on Entra-joined machines. Finally, native support on Windows Home Editions isn't part of the Entra-joined device list, which typically targets organization-owned Pro or Enterprise SKUs for full management and policy coverage. Question 20. You've been asked to minimize infrastructure management while providing identity services for cloud apps. The company currently runs ADDS on premises and wants to use the same user identities in the cloud without deploying domain controllers in Azure. Which approach best aligns with the platform's design and reduces operational overhead? Select one answer. A. Leverage Microsoft Entra ID by extending the existing on-premises Active Directory implementation to it and manage identities natively in the cloud. B. Deploy ADDS domain controllers on Azure VMs and rely on group policy for cloud app access. C. Migrate all applications to on-premises ADDS and decommission Microsoft Entra ID. D. Create a separate directory for each application to isolate identities. Correct answer A. Leverage Microsoft Entra ID by extending the existing on-premises Active Directory implementation to it and manage identities natively in the cloud. Here's the playbook behind that choice. Then we'll wrap. First, extending on-premises AD to Microsoft Entra ID lets you use one cloud-managed directory without running domain controllers in Azure, thereby reducing IaaS overhead while maintaining the same identities across apps. Next, B adds VM management and leans on GPO, which isn't how modern cloud apps authorize access. Conditional access and app assignments live in Entra, not group policy. Meanwhile, C contradicts the goal by pushing everything back on premises and removing cloud identity benefits like SaaS SSO and lifecycle automation. Finally, D fragments identity across multiple directories, complicating sign-in and governance instead of simplifying it. For example, sync users to Entra and assign SaaS apps there. Identities stay consistent, and you avoid patching or monitoring extra domain controllers in Azure altogether. Question 21. Fill in the blanks by selecting the correct options from the drop-down menus. Azure Private Link provides private connectivity from a virtual network to Azure PaaS or partner services. Let's unpack that in a snap so it sticks. First, private connectivity means traffic stays on Microsoft's backbone and never traverses the public internet, which reduces exposure and simplifies compliance. Next, the destination can be Microsoft PaaS offerings like storage, SQL database, and Key Vault, as well as approved partner or customer services exposed through Private Link service, so your VNet reaches them over private endpoints. However, items like broadcast address, overlapping CIDR, or DNS server aren't connectivity targets or features here. They're networking concepts that don't enable Private Link by themselves. For example, a finance app in a VNet can read from a storage account via a private endpoint IP inside the subnet, thereby avoiding public endpoints while keeping throughput high and latency predictable. Question 22. Fill in the blanks by selecting the correct options from the drop-down menus. When creating a virtual network, you must specify the IP address space and provide details like subscription, resource group, name, and region in the Azure portal. Quick heads up before we dive deeper. Here's why those choices fit. First, the IP address space defines the VNet CIDR boundaries, so every subnet and private endpoint must fit inside that range. Choosing it up front prevents overlaps with on-prem networks during hybrid connectivity. Next, subscription, resource group, name, and region are the mandatory administrative fields the portal needs to place and track the VNet, which ensures billing, RBAC, and policy are applied at the right scope. Meanwhile, DNS server settings are optional and can be configured later, so they aren't part of the initial requirement. Likewise, availability zones relate to compute redundancy, not VNet creation, and broadcast address is merely a reserved subnet value, not an input you supply. Question 23. For each property of a network security group NSG rule, drag it to its correct description. Defines inbound traffic filter criteria. Answer, source. Defines outbound traffic filter criteria. Answer, destination. Specifies protocol and port range or predefined service. Answer, service. Sets order of rule evaluation, lower equals higher precedence. Answer, priority. Let's break it down clearly so it sticks. First, source governs where inbound traffic originates, such as an IP range tag or application security group, so it fits the inbound criteria statement. Next, destination targets the outbound side by defining where traffic is going, for example, a subnet, service tag, or specific IPs. Additionally, service captures protocol and ports like TCP 443 or a built-in label such as RDP or SSH, which simplifies rule authoring. Finally, priority determines evaluation order. Lower numbers are processed first. Therefore, a deny at priority 100 beats an allow at 200, preventing unintended access in real deployments. Question 24. For each statement below, indicate whether it is true or false. An NVA can be deployed from third-party providers such as Cisco or Barracuda. Answer: true. With microsegmentation, traffic bypasses the firewall for performance optimization. Answer: false. NVAs can inspect traffic at OSI Layer 4 and Layer 7 if application aware. Answer: true. If traffic is routed through an NVA, failure of that NVA may disrupt communication. Answer: true. Now, let's unpack the logic so it sticks. First, Azure Marketplace offers NVAs from vendors like Cisco, Checkpoint, and Barracuda, so third-party deployment is standard. However, microsegmentation is about enforcing inspection between segments, not skipping the firewall. Hence, the second statement is false. Meanwhile, many NVAs filter at Layer 4, and when application aware, analyze Layer 7 to control protocols like HTTP or SQL. Finally, because the NVA sits in the traffic path, a failure can interrupt flows unless you design high availability. Consequently, the last statement is true. Question 25. Fill in the blanks by selecting the correct options from the drop-down menus. Azure Front Door is designed for global load balancing at Layer 7, while Azure Load Balancer provides regional load balancing at Layer 4. Quickly, here's how to think about it. Front Door operates at the application layer, so it makes routing decisions using HTTP or HTTPS features and spreads traffic across global backends, which is ideal for multi-region web apps and failover scenarios. By contrast, Azure Load Balancer works at the transport layer, handling TCP or UDP flows within a region, thereby distributing connections across virtual machines or scale sets in the same geography. Put simply, Front Door equals global and Layer 7 intelligence, whereas Load Balancer equals regional and Layer 4 throughput. Question 26. For each statement below, indicate whether the answer is true or false. Network Watcher becomes automatically available when you create a virtual network in an Azure region. Answer: true. Packet capture can only be triggered by operating system tools or third-party utilities. Answer: false. The IP Flow Verify tool requires specifying a 5-tuple, including protocol and port information. Answer: true. VPN troubleshoot results can include recommended actions with documentation links. Answer: true. Now let's walk through the reasoning so it sticks. To begin with, Network Watcher is auto-enabled per region when you create a VNet, so you can start diagnostics without extra setup. Conversely, packet capture isn't limited to OS tools. Rather, you can trigger captures remotely through Network Watcher in the portal, PowerShell, or the REST API. Hence, the statement is false. Additionally, IP Flow Verify evaluates traffic using the 5-tuple of source and destination IPs, source and destination ports, and protocol. Therefore, that statement is true. Finally, VPN Troubleshoot not only runs checks, but also surfaces recommended remediation steps with links to documentation, so the last statement is true as well. Question 27. What is true about changing the assignment method of a public IP address in Azure? Select one answer. A. You can change it only if the public IP isn't associated with a resource. B. You can always change it regardless of association. C. You can only change it after the IP is deleted and recreated. D. You can never change the assignment method once created. Correct answer, A. You can change it only if the public IP isn't associated with a resource. Switching into the reasoning so it's crystal clear. First, Azure lets you modify the assignment method static or dynamic only when the IP is unattached, because the NIC or load balancer binding locks that property during use. However, saying you can always change it isn't accurate, since an attached IP may block edits and risk connectivity. Likewise, recreating the IP isn't required if you simply detach it and then change the method, so option C overstates the process. Consequently, It's not never changeable, it's conditionally changeable when the resource association is removed. For example, detach the public IP from a VM's NIC, switch from dynamic to static in the portal, then reattach to keep a stable address going forward. Question 28. Which statement about associating public IPs to an application gateway is correct? Select one answer. A. Only dynamic IPs are supported. B. Public IPs must be associated through a network interface. C. Application gateways cannot use public IPs. D. Static public IPs are available only on certain SKUs. Correct answer. Static public IPs are available only on certain SKUs. Again, let's break it down quickly so it sticks. Application Gateway supports both dynamic and static public IPs, yet static addressing requires supported SKUs such as the V2 families. Hence, D is the accurate statement. Meanwhile, option A falls apart because dynamic only isn't true when the SKU supports static. Moving on, option B is incorrect since an application gateway doesn't use a NIC like a VM. You attach the public IP directly to the gateway's front-end configuration. Lastly, option C is simply wrong because application gateways absolutely can use public IPs to expose front ends to the internet. Question 29. Arrange the steps for configuring a public DNS zone in Azure DNS in the correct order. 1. Create DNS zone in Azure. 2. Get Azure DNS name server details. 3. Update registrar NS record with Azure DNS details. Verify domain delegation using SOA record. Configure custom DNS records. Let's unpack the flow so it lands. First, you create the DNS zone to establish Azure as the hosting authority for that domain. Next, you retrieve the zone's assigned name servers, which you'll publish at your domain registrar. Subsequently, you update the registrar's NS records so the internet delegates your domain to Azure DNS. Then, you verify delegation by checking the SOA record, confirming queries are reaching Azure. Finally, you add A, CNAME, MX, or TXT records for apps and services. For example, pointing www to a front door endpoint, while SPF and DKIM TXT records secure mail delivery. Question 30. A datum wants to distribute internet traffic across multiple web tier VMs while automatically excluding failed VMs from handling client requests. Which Azure service feature combination satisfies these requirements? Select one answer. A. Internal load balancer with VPN connection. B. Public load balancer with health probes. C. System routes with force tunneling. D. Azure Bastion with NAT rules. Correct answer B. Public load balancer with health probes. All right, let's unpack this succinctly so it clicks. First, a public load balancer spreads internet-facing traffic across back-end pool VMs, and its health probes continuously test endpoints. Consequently, any VM that fails a probe is taken out of rotation until healthy again. Meanwhile, an internal load balancer handles private traffic or cross-premises patterns, not public internet distribution, so option A doesn't align. Furthermore, system routes and force tunneling shape egress paths, but provide neither load distribution nor health checks, which rules out option C. Finally, Azure Bastion offers secure browser-based RDP or SSH to VMs. However, it isn't a data path load balancer and has no health probing for app traffic, so option D is off target. Question 31. Which two features describe Azure Load Balancer? Select two answers. A. Delivers global DNS-based load balancing. B. Supports inbound and outbound TCP or UDP flows. C. Operates at OSI Layer 4. D. Provides web application firewall capabilities. Correct answers. B. Supports inbound and outbound TCP or UDP flows. C. Operates at OSI Layer 4. Here's the quick logic, then we'll move on. Azure Load Balancer is a transport layer service, so it operates at Layer 4 and balances millions of TCP or UDP flows in both directions across backend instances. By contrast, global DNS-based load balancing comes from Azure Traffic Manager, not Load Balancer, and Web Application Firewall features live with Application Gateway or Azure Front Door, not this Layer 4 service. Question 32. Which two types of agents can be installed to enable connection monitor checks on hosts? Select two answers. A. Network Watcher Agent VM. B. Log Analytics Agent. C. Diagnostic Storage Agent. D. Azure Monitor Agent. Correct answers: A. Network Watcher Agent VM. B. Log Analytics Agent. Zooming into the why so it lands. First, the Network Watcher Agent VM extension runs on Azure VMs to perform connection monitor tests and collect network diagnostics, so it's essential for in-Azure endpoints. Next, the Log Analytics Agent installs on on-premises or other non-Azure machines, enabling hybrid checks that report back to Azure Monitor and Network Watcher. However, Diagnostic Storage Agent isn't tied to Connection Monitor, and the Azure Monitor Agent focuses on telemetry collection generally, not the specific active network probes Connection Monitor requires today. Question 33. Your company wants the same domain name to resolve differently depending on whether the request comes from inside the corporate network or from the internet. Which Azure DNS feature supports this requirement? Select one answer. A. DNS Security Extensions DNSSEC. B. Alias Record Sets. C. Split Horizon DNS. D. Automatic Global Load Balancing. Correct answer: C. Split Horizon DNS. Here's the logic in plain terms. First, Split Horizon DNS lets you host both a public zone and a private zone for the same domain, so internal clients resolve to private IPs while internet clients get public IPs, ensuring context-aware answers without app changes. Meanwhile, DNSSEC merely signs records for integrity and authenticity, not different views, so it doesn't meet the requirement. Additionally, alias record sets point to Azure resources like front door or public IPs, but they don't change answers based on query origin. Finally, automatic global load balancing is a traffic manager or front door capability for routing users to endpoints, not a DNS split function. For example, Contoso.com can answer 10.15 for employees on the corporate VNet and 5217.x.y for internet users, all thanks to Split Horizon DNS. Question 34. For each Azure Storage Account type or SKU, drag it to the correct service scope: blob, queue, table, and Azure files including ADLS. Answer: Standard General Purpose V2, GPv2, block blobs and append blobs only. Answer: Premium block blobs, Azure files only. Answer: Premium file shares, page blobs only. Answer: Premium page blobs, quickly shifting into the why so it sticks. First, GPv2 is the versatile default because it supports blobs, queues, tables, and Azure files in one account, so it fits the broadest scope. Next, Premium block blobs is optimized for high transaction rates on block or append blobs. Therefore, it matches the block blobs only statement. Additionally, Premium file shares targets Azure files with enterprise scale and SMB or NFS performance, which is why Azure files only maps there. Finally, Premium page blobs is specialized for page blobs used by disks and databases, so it aligns with the page blobs only requirement. Question 35. Fill in the blanks by selecting the correct options from the drop-down menus. Premium page blobs are ideal for storing index-based and sparse data structures in addition to operating systems, data disks, and databases. Let's break that down for clarity. Page blobs support random read and write access in fixed-size 512-byte pages. Therefore, they fit workloads that jump around an index, as well as datasets with lots of empty ranges where sparse allocation avoids paying for unused space. By contrast, columnar append-only or streaming patterns align better with block blobs, while compressed-only, transactional rows, or hierarchical aren't characteristics that determine page blob suitability in this context. Question 36. For each statement below, indicate whether the answer is true or false. A blob can exist without being in a container. Answer: false. A container can store an unlimited number of blobs. Answer: true. A storage account can contain an unlimited number of containers. Answer: true. You must create a container before you can upload data. And true. Quick check. Here's why each one lands. First, blobs always live inside a container. There's no free-floating blob in Azure Storage, hence the first is false. Next, Microsoft doesn't fix upper limit on blob count per container, so capacity is governed by total account limits and practical throughput, making the second true. Likewise, there's no fixed cap on the number of containers in an account, so the third is true as well. Finally, uploads target a specific container path, which means you must have that container created beforehand, confirming the last statement as true. Question 37. Arrange the evaluation flow of a lifecycle rule. Correct order. Set the if condition. Evaluate the if condition. Execute the ROT. Then action. Apply results and continue on next cycle. Now, let's walk it through so the sequence sticks. First, you define the if condition, usually a time-based filter like older than 30 days, which targets the eligible blobs for this run. Next, the service evaluates that if condition across the scoped set, determining exactly which items qualify right now. Then, once the condition is satisfied, the engine executes the bot. Then action, for example, moving blobs to cool or archive, or deleting them when required. Finally, those results are committed and the policy waits for the next evaluation window, repeating the same logic on the next cycle so changes persist reliably over time. Question 38. A media team wants viewers in multiple regions to experience lower read latency, and they want regional compute farms to process the same set of blobs without repeatedly pulling data across regions. What should be configured? Select one answer. A. Object replication with a policy mapping the source containers to destination containers in the other regions. B. RAGRS, so the secondary region can be read during outages only. C. Lifecycle rules to move all data to archive in the destination accounts. D. A single managed disk attached to VMs in both regions. Correct answer. A. Object replication with a policy mapping the source containers to destination containers in the other regions. Now onto the why so it clicks. First, object replication asynchronously copies blobs at the container level across regions, thereby placing data close to users and compute while keeping sources and destinations in sync. Next, RAGRS mainly helps during failovers. It doesn't give you ongoing, policy-driven, multi-region copies for normal operations, so it misses the requirement. Meanwhile, archive increases retrieval latency and is unsuitable for active regional processing. However, managed disks are zonal or regional VM storage, not a cross-region object distribution mechanism. For example, with object replication, when editors upload a new video in region A, the blob policy replicates it to region B and C containers, so viewers there read locally and analytics jobs run against the local copies without cross-region pulls. Question 39. For each statement below, indicate whether the answer is true or false. Data on an Azure file share is encrypted at rest and in transit. Answer true. Azure Blob Storage is the preferred service for storing shared configuration files needed by multiple VMs. Answer false. Clients can, by default, access Azure file shares from anywhere with internet connectivity. Answer true. The replication setting of the storage account controls Azure file share data redundancy. Answer true. Let's connect the dots quickly so this sticks. To start, Azure Files enables encryption at rest in the data center and supports encryption in transit over SMB or REST, so the first statement holds. On the other hand, shared app configuration used by multiple VMs is a classic Azure file scenario, not blob storage, which makes the second statement false. Moving on, when network access rules allow it, clients on the internet can mount or reach Azure file shares using supported protocols, so the third is true. Finally, redundancy for Azure Files rides on the storage account's replication choice, such as LRS, ZRS, or GRS. Therefore, the last statement is true as well. Question 40. For each storage tier, drag it to the correct description, stores data on SSDs, and provides consistent high performance and low latency. Answer, Premium, available only in file storage account kind. Answer, Premium, not available in all Azure regions. Answer, Premium, available in all Azure regions. Answer, Standard, deploys in GPv2 storage accounts. Answer, Standard with LRS, ZRS, GRS, and GZRS. Answer, Standard, available with LRS and ZRS in some regions. Answer, Premium. Quick context before we move on. Premium Azure Files uses SSDs in the file storage account type, so it offers low latency but isn't in every region and typically supports LRS and ZRS only, sometimes region dependent. Conversely, standard rides on HDD-backed GPv2 accounts is available everywhere and supports the full redundancy lineup LRS, ZRS, GRS, and GZRS for broad resilience options. Question 41. Identify the statements that correctly describe standard versus premium storage accounts. Select 3 answers. A. Standard accounts use HDDs and provide the lowest cost per GB. B. Premium accounts use SSDs and provide consistent low latency. C. You can convert between standard and premium accounts at any time. D. Premium file shares support SMB and NFS for high-performance enterprise scenarios. E. Premium page blobs handle queues, tables, and files alongside page blobs. Correct answers. A. Standard accounts use HDDs and provide the lowest cost per GB. B. Premium accounts use SSDs and provide consistent low latency. D. Premium file shares support SMB and NFS for high-performance enterprise scenarios. Here's the quick rundown to lock it in. To start, standard targets cost efficiency on HDDs, so it typically offers the lowest price per gigabyte. Meanwhile, premium is SSD-backed, delivering predictable low latency for demanding workloads. Additionally, premium file shares are an Azure Files-only SKU that supports SMB and NFS to meet enterprise performance needs. However, you can't simply flip a standard account to premium. You create a new account and migrate data. So option C is incorrect. Likewise, premium page blobs are only page blobs. They don't host queues, tables, or files, which makes option E wrong. Question 42. Which storage account types explicitly include support for data lake storage capabilities under blob storage? Select 2 answers. A. Premium file shares. B. Premium page blobs. C. Standard general purpose v2 GPv2. D. Premium block blobs. Correct answers. C. Standard general purpose v2 GPv2. D. Premium block blobs. Quick context before we wrap. GPv2 includes full blob storage features plus ADLS capabilities, so it's the mainstream choice when you need hierarchical namespaces and big data analytics integration. Likewise, premium block blobs also sit in the blob storage family and explicitly support data lake storage features, delivering SSD-backed performance for analytics pipelines. By contrast, premium file shares is Azure Files only and doesn't expose blob or ADLS functionality, and premium page blobs are limited to page blobs for disks rather than the ADS feature set, so they don't meet the requirement. Question 43. Your team wants users to access blob data using a custom domain, such as blobs.contoso.com, instead of the default Azure storage URL. You plan to use a direct DNS mapping method. What should you configure? Select 1 answer. A. Create an A record pointing blobs.contoso.com to the storage account's public IP. B. Create a TXT record containing the storage account name. C. Create a CNAME from blobs.contoso.com to storage account. Table.core.windows.net. D. Create a CNAME from blobs.contoso.com to storage-account. blob.core.windows.net. Create a CNAME from blobs.contoso.com to storage account. blob.core.windows.net. All right, quick walkthrough of why that's the one. With direct mapping, Azure Blob Storage expects a DNS CNAME that points your custom host to the blob endpoint. So clients resolve blobs.contoso.com to account, blob.core.windows.net, and requests are served correctly. By contrast, an A record to a public IP won't work because storage endpoints are addressed by names, not fixed static IPs that you manage. A TXT record only carries metadata or verification text and doesn't affect routing at all. And mapping to account, table.core.windows.net targets the table service, not blob, so it wouldn't route blob requests properly. For example, after creating the CNAME, a call to http:/blobs.contoso.com/container-file.jp resolves to the blob endpoint seamlessly without changing your application URLs. Question 44. You must ingest a 50 TB dataset from an on-premises site with limited bandwidth within 1 week. The plan should minimize network use and administrative overhead. Select 1 answer. A. Use Azure Databox Disk to receive SSDs from Microsoft, copy the data locally, then ship the disks back for upload to blob storage. B. Throttle as copy over the WAN and run continuously for several weeks. C. Mount an Azure managed disk on-prem and copy files directly to it. D. Upload via the Azure portal in batches throughout the week. Correct answer. A. Use Azure DataBox Disk to receive SSDs from Microsoft. Copy the data locally, then ship the disks back for upload to blob storage. Let's break this down quickly so it sticks. First, DataBox Disk is designed for high-volume timebox transfers. You copy locally at LAN speed, ship the SSDs, and Azure ingests the data in the data center, which slashes WAN use and admin effort. Meanwhile, throttling as copy over the WAN still relies on constrained bandwidth and likely misses the 1-week window. Moreover, you can't mount Azure Managed Disks on-prem for direct file copies. They're VM-attached storage in Azure only. Finally, portal uploads are manual and impractical for 50 terabyte, adding overhead without ensuring the deadline. Question 45. Which access tiers apply a per GB data access charge for reads? Select 2 answers, A. Hot, B. Cool, C. Cold, D. Archive. Correct answers, B. Cool, Archive. Now, let's unpack this in plain English so it sticks. First, the Cool tier charges per GB when you read data, which is why it's cheaper to store but pricier to access compared to Hot. Next, Archive also bills per GB for reads after you rehydrate objects, and those read costs are the highest of the tiers. It's built for rare access with long retrieval times. Meanwhile, Hot does not add a per GB read charge, favoring frequent access with higher storage rates instead. Finally, Cold isn't the tier in focus for this question set. Here, the cost on read callout applies specifically to Cool and Archive, which is the behavior you need to remember for exams and real-world trade-offs. Question 46. Fill in the blanks by selecting the correct options from the drop-down menus. Azure compute expenses are priced on a per-hour basis, but billed on a per-minute basis. Here's the quick breakdown so it sticks. Azure publishes VM pricing per hour for easy comparison. However, the meter charges only for the minutes you actually run, which avoids paying for a full hour when you use just part of it. For example, if a VM runs for 7 minutes, you're billed for 7 minutes, not 60, making short test runs more cost-efficient. Likewise, models like per second, per day, or per month aren't how compute consumption is measured here. The combo is hourly pricing with minute-level billing to balance clarity and fairness. Question 47. For each Azure Automation Service feature, drag it to the appropriate description in the correct match column. Responds automatically to monitored events, for example, fixing errors. Answer, process automation, tracks software updates and lets you take action. Answer, configuration management. Schedules and manages OS patches, including results review. Answer, update management, quickly shifting into the Y to cement it. Process automation runs runbooks in response to alerts or schedules. So it's the piece that auto-reacts when an error is detected and can remediate issues without manual steps. Meanwhile, configuration management inventories machines for available updates and lets you include or exclude them, which is why it matches the software update tracking description. Finally, update management is the engine that actually orchestrates patch deployments on a schedule and then reports compliance, neatly aligning with the OS patching and results review requirement. Question 48. For each service type, drag it to the correct description and examples. Resources pinned to a specific zone. Answer, zonal services. Services replicated automatically across all zones. Answer, zone redundant services. Here's the quick logic so it sticks. First, zonal services like Azure VMs, managed disks, and standard public IPs are created in a chosen availability zone, which gives you control over placement and fault isolation. Next, zone redundant services replicate across zones by design, so a single resource such as zone redundant storage or Azure SQL database spans zones to survive a single zone failure without manual distribution. Items like Backup Vault and Autoscale aren't classifications of zonal or zone redundant services, so they don't match these descriptions. Question 49. For each statement below, indicate whether it is true or false. Virtual machine scale sets remove the need to pre-provision VMs. Answer. All VMs in a scale set must use the same base OS image and configuration. Answer. True. VM scale sets cannot integrate with load balancing services. Answer false. VM scale sets support both manual and automated scaling. Answer true. Here's the quick reasoning so it lands. First, VMSS dynamically creates and deletes instances, so you don't pre-build a fixed fleet. Next, scale sets maintain consistency by deploying a common base image and model across instances, simplifying updates. Meanwhile, VMSS tightly integrates with Azure Load Balancer and Application Gateway, so the claim they can't integrate is false. Finally, scaling can be manual via rules or automated by metrics or schedules, meaning you can mix approaches to fit demand. Question 50. Fill in the blanks by selecting the correct options from the drop-down menus. The basic service plan provides built-in load balancing, but lacks advanced autoscale, while the standard service plan includes autoscale that adjusts VM instances automatically to match traffic needs. I'm going to explain now, so follow along. First, Basic is intended for lower traffic or dev workloads. It gives you load balancing to spread requests, but doesn't scale out automatically, so you'd add or remove instances yourself. Meanwhile, Standard targets production. It brings metrics-driven autoscale that increases or decreases instances based on demand, thereby maintaining performance and controlling cost. Consequently, for real-world web apps expecting variable traffic, Standard keeps things responsive without manual intervention, whereas Basic suits steady, smaller environments or testing where you can live without autoscale. Question 51. For each statement below, indicate whether the answer is true or false. Azure automatically assigns a default subdomain of azurewebsites.net when you create a web app. Answer, true. A custom domain must always be purchased from a third-party registrar. Answer, false. CNAME records remain valid even when the underlying IP address changes. Answer, true. You must enable and validate a custom domain in the Azure portal before publishing. Answer, true. I'm going to explain now, so follow along as we connect each choice to the platform behavior. First, every new web app gets a default .azurewebsites.net host, so you can browse immediately without buying a domain. Next, Azure lets you purchase domains directly in the portal, as well as use third-party registrars, therefore it isn't always third-party. Meanwhile, a CNAME points one hostname to another name rather than an IP, so when the provider's IP changes, the alias keeps working automatically. Finally, before traffic flows to your vanity name, Azure requires you to add and verify the custom domain, ensuring ownership and correct DNS mapping, and only then can you publish confidently. Question 52. Which type of workloads are virtual machine scale sets especially designed to simplify building large-scale services for? Select one answer. Correct answer: B. Large compute, big data, and containerized workloads. I'm going to explain now, so follow along as we connect the choice to how VMSS works. First, VM scale sets shine when you need to elastically add or remove many identical VM instances, therefore they're ideal for massive compute farms, analytics engines, and container orchestrators that surge with demand. Moreover, they integrate with autoscale and load balancing, so as telemetry rises, instances roll out uniformly, keeping performance steady without manual provisioning. Conversely, desktop productivity apps are not a primary VMSS scenario since they're user-centric rather than scale-out server workloads. Likewise, small on-premises apps don't fit because VMSS is a cloud-native pattern, and file backup or archival storage maps to Azure Storage Services, not to compute scaling. Question 53. Which two factors should you review before adding a new application to an existing app service plan? Select two answers. A. Remaining capacity of the current plan. B. Geographic region requirements. C. Database schema design. D. Operating system of client browsers. Correct answers. A. Remaining capacity of the current plan. B. Geographic region requirements. I'm going to explain now, so follow along as we connect those choices to real-world planning. First, an app service plan shares CPU, memory, and disk across all apps on that plan. Therefore, you should confirm there's headroom. Otherwise, new apps may throttle or cause downtime. Next, location matters. Some apps must run in specific regions for compliance or latency, so you need to ensure the plan is in the right geography or create a new plan closer to users. Meanwhile, database schema design is important for the app, but doesn't determine whether it can join a plan. It's orthogonal to compute hosting. Finally, Client Browser OS has nothing to do with app service plan capacity or region selection, so it's not a deciding factor here. Question 54. What is the current supported range for the number of virtual machine instances in an Azure App Service plan? Select one answer. A. 110, B. 220, C. 330, D. 550. Correct answer, C. 330. I'm going to explain now, so follow along as we connect the choice to the platform limits. First, app service plans in the standard and above tiers can scale out from 3 up to 30 instances per plan, giving you significant headroom for traffic spikes. Meanwhile, 1 to 10 is too low because the platform supports more than 10. 2 to 20 starts at the wrong minimum and caps below the current maximum, and 5 to 50 overshoots the supported range. Therefore, when planning autoscale rules, keep the min and max within the 3 to 30 window to stay aligned with what the service allows today. Question 55. A developer clones an existing deployment slot. They want to know if the cloned configuration can be modified and whether all elements will follow during a swap. What is true about this scenario? Select two answers. Answer A, cloned configuration is editable. C, some settings follow the swap while slot-specific ones remain. I'm going to explain now, so follow along as we connect each choice to how slots behave. First, once a slot is cloned, you can change its configuration independently, so the clone configuration is editable and doesn't have to mirror the source forever. Next, during a swap, only certain settings travel with the content, such as app settings marked as slot agnostic, while slot-specific items like connection strings set as slot setting, custom domains, and certificates stay with their original slot. Therefore, some settings follow the swap, and others remain in place. Consequently, the claim that all slot-specific settings always move is incorrect, and so is the idea that the cloned slot must remain identical to the source. Question 56. Your company plans to host applications from multiple competing vendors on a shared cloud server. Management insists on the strongest possible isolation between workloads. Which option should you select? Select one answer. A. Containers on Azure Container Instances. B. Virtual machines on Azure. C. Bare metal servers with multiple apps installed directly. D. Containers deployed with Azure Kubernetes Service. Correct answer. B. Virtual machines on Azure. I'm going to explain now, so follow along as we connect the choice to isolation levels. First, virtual machines provide the strongest tenant boundary here because each workload gets its own guest OS, hypervisor isolation, and dedicated kernel context. Consequently, noisy neighbor or cross-app interference is minimized. Meanwhile, containers, whether ACI or AKS, share a host OS kernel. Therefore, although lightweight and secure for many cases, they do not match VM-level isolation demanded for competing vendors. Likewise, installing multiple apps directly on one bare metal server offers the weakest separation since everything shares the same OS. Hence, a misconfiguration could impact others. Practically, imagine two rival SaaS providers. Placing each in its own VM with separate NSGs and managed identities ensures cleaner boundaries, whereas sharing a container host would couple them to the same kernel and risk policy overlap. Question 57. Which statement about Azure Container Apps is correct? Select one answer. A. It exposes full Kubernetes APIs for cluster customization. B. It only supports monolithic applications without scaling. C. It provides all up-to-date server resources to keep applications stable and secure. D. It requires developers to patch and manage Kubernetes nodes directly. Correct answer, C. It provides all up-to-date server resources to keep applications stable and secure. I'm going to explain now, so follow along as we connect the choice to the service model. First, Azure Container Apps is a serverless container platform. It abstracts the Kubernetes control plane and nodes, automatically keeping the underlying infrastructure patched and current. Therefore, you don't manage nodes or the cluster directly, which makes options A and D incorrect because ACA intentionally hides full Kubernetes APIs and node operations. Moreover, ACA is designed for microservices and event-driven apps with built-in autoscaling via KEDA triggers, so the claim that it only handles monoliths without scaling is also false. In practice, you push a container image, define revisions and scale rules, and Azure handles the rest, keeping the environment secure and up to date. Question 58. Select one answer. Your VM runs on an Azure physical server that fails. Azure automatically moves your VM to a healthy host, but the process takes several minutes. What does this mean for your application? A. The VM remains available during migration. B. The application may be unavailable until the move completes. C. The VM restarts but continues serving requests without interruption. D. Azure deletes the VM and recreates it from template. Answer B. The application may be unavailable until the move completes. I'm going to explain now, so follow along as we connect the choice to how Azure behaves. During self-healing host migration, the VM is paused and moved to a healthy node. Therefore, your app experiences a brief outage until the move is finished. Meanwhile, the VM does not keep serving traffic during the move, so option A is incorrect. Likewise, it is not a seamless restart that continues handling requests, so option C does not match reality. Finally, Azure does not delete and recreate your VM from a template in this scenario, meaning option D is also wrong. Think of it like moving a running laptop to a new motherboard in a few minutes. Naturally, the laptop must pause, then it resumes exactly where it left off once the hardware is ready again. Question 59. For each log search alert rule component, drag it to the appropriate box in the correct match column to match it against its definition. Query that runs every time the alert rule fires. Log query. Time range over which the query evaluates data. Time period. How often the query execution is scheduled. Frequency. Trigger point that causes an alert to be created. Threshold. I'm going to explain now, so follow along as we connect each definition to its role in Azure Monitor Alerts. First, log query is the KQL the rule executes. Whenever the rule runs, this query returns the dataset used to test the condition, so it directly defines what you are measuring. Next, time period sets the historical window, for example, the last 30 minutes, from which the query reads data. Consequently, it frames the evidence you evaluate. Then, frequency controls cadence, such as every 5 minutes. Thus, the platform schedules how often the query wakes up and evaluates the window. Finally, threshold specifies the boundary value that, when met or exceeded by the query result, generates the alert and triggers actions. For instance, average CPU over the last 30 minutes greater than 80%. Together, these 4 pieces define what to check, over what data, how often to check it, and when to raise the alert, which is exactly how reliable monitoring rules are built in practice. Question 60. For each statement below, indicate whether it is true or false. Activity log alerts can notify you if a virtual machine is deleted. True. Service health alerts must be scoped to a specific resource group. False. Administrative category alerts include actions such as VM power operations. True. When creating a service health alert, you must select a specific resource as the target. False. I'm going to explain now, so follow along as we connect each statement to how Azure alerts work. First, activity log alerts watch the Azure activity log. Therefore, they can trigger when a VM is deleted or any similar control plane action occurs. So that is true. Next, service health alerts report Azure platform incidents and maintenance by region and service. Consequently, they are not tied to a single resource group, which makes the second statement false. Then, the administrative category in the activity log covers operations like start, stop, deallocate, and restart on VMs, hence the third statement is true. Finally, when you create a service health alert, you target an Azure subscription and regions or services rather than a specific resource, so the last statement is false.